Good morning. I'm Suresh Vasudevan, CEO of Clockwork Systems. Thank you all for joining me on this panel discussion today, where we'll talk a little bit about what it takes for enterprises to scale AI in an economic manner. And I am really grateful to you all for joining me today. I'm extremely grateful to my fellow panelists, Vinita and Chris. And let me just start by briefly asking each of you to introduce yourselves. Vinita.
Sure. Hi, everyone. Excited to be on this panel discussion. My name is Vinita Ananth. I'm from Nebius. I have spent my entire career, actually a good part of my career, at AWS and Azure, helping enterprises figure out how to make AI work at scale. And now I am at a GPU native cloud where we're obsessed with the exact a question that this panel is about, which is how do you close the gap between the 400 billion and plus rapidly increasing amounts of money that's being spent on AI infrastructure and the actual business returns. And this, the gap in infrastructure and operations problem is what I work on every day.
Hi, everybody. Suresh, thanks for having me. My name is Chris Morgan. I am one of the founders and CEO of a company called 7SG. We were founded to solve the problem of connecting kind of the IT past with an AI future. We've quickly determined that there was a gap going on between those people who were really very much driving the AI agenda and their knowledge and experience with deploying and integrating with legacy IT implementations and architectures was causing a problem for enterprise customers on deployment and scale out. So we've developed an agentic platform and a series of other technologies and processes that help enterprises adopt AI projects at scale.
Thank you, Vinita. Thank you, Chris, both of you for joining us today on the panel. Let me start with a little bit of context. PricewaterhouseCoopers, PwC, came out with their, I think, 29th annual CEO survey about a month or so ago, where they talked to almost 4,500 CEOs across nearly 100 countries around the world. And what was interesting was that on the one hand, you saw rapid adoption of AI. More than 80% of the organizations surveyed were all investing in AI, embracing AI. And yet only 12% of those companies were able to claim that they saw both revenue increases and cost decreases as a result of investing in AI. What was interesting was that the number one concern expressed by all these CEOs, even though 80% of them had already embraced AI, the number one concern was quite simply that they were not doing enough fast enough to transform their companies to take advantage of AI. So that was sort of what they were most fixated on. Now, there are a whole host of things that these 12% high flyers have done differently in order to see the merits, the benefits of AI sort of translating into business outcomes. But today in this panel, what we're going to talk about is specifically focused on one of those dimensions, which is around AI infrastructure and what it takes to manage AI infrastructure, to scale AI infrastructure as AI projects start to go from pilot to production scale. And there are numerous surveys that speak to AI infrastructure concerns as being top of mind. And as you peel the onion on what are the concerns underpinning AI infrastructure, three of those surface up as the most significant ones. The first is around costs. The costs are high, the costs are unpredictable, and the ROI is uncertain around AI. So that's the first topic that comes up over and over again. The second is around supply chain, and both in terms of how do I secure supply, but also how do I retain flexibility? How do I trade off costs with various options around how I can secure my infrastructure? And lastly, sort of, do I have the in-house talent? How do I partner with service providers and balance on-prem investments with cloud investments, in-house talent with third-party talent, et cetera? So that's really the second broad topic, is around supply chain strategy. And the last one is around the reliability of the infrastructure itself. That spans everything from how do I run my GPU clusters in a reliable manner to how do I make sure that my data pipelines are able to feed my AI needs, to how do I make sure I have the right governance controls and security controls and risk controls around the use of AI. Those are the top three concerns that have come up in numerous studies around AI infrastructure. So I'm going to start with really the cost. And Vinita, I'll start with a question for you. it's and sort of let me motivate this. I had a recent meeting with the senior engineering team of a Fortune 50 company. This is one of the largest tech companies. And what was interesting was that the entire team, one of the key metrics for this team that was responsible for AI infrastructure was around the efficiency measure. They were using MFU, and sort of that was literally linked to their incentives for the year. And that stemmed from a deeper concern in the industry around utilization of GPU clusters being somewhere in the 30 to 40% zone. So, Vinita, can you tell us a little bit about, sort of based on your experience, what drives that utilization rate? What are the biggest factors influencing that?
Yeah. So I'll take one step back. You're absolutely right when it comes to sort of thinking about what economics matters, right? CIOs are definitely looking at many metrics. And one of them is definitely GPU utilization. The other is costs per inference request. As we all know, today the training costs and inference costs are quite different, and I'll touch upon those workloads like in a moment. But we are also looking at that metric as a critical metric as what should be tracked. And the third thing is really time to production, right? So if you've got pilots running, you're thinking about taking these pilots into production, how long does it take to do that? And what is the ROI working backwards, in tracking that velocity and not just the spend. So going to the first question you asked, which is, yes, the industry is seeing 30 to 50% utilization. A lot of the GPUs are idle. And there's several reasons for this. The first could be underutilization because of over-provisioning. If you look at the way that provisioning was done in the CPU world, we provisioned for the worst case demand, right? And that meant that you were over provisioning and it just became a practice, but it's worse now because GPUs are 10 to 20x more expensive than CPUs per hour. There's also the job scheduling inefficiency, in training jobs and inference. But if you look at training, if you don't perfectly fill the GPU memory and it requires, suppose you need 1.5 times GPU worth memory, but you're essentially wasting half a GPU, multiply that by thousands of jobs, right? You're also seeing, on the inference side, because you don't, it's a job that runs continuously, but it's hard to predict what's going to be the pattern of usage. Again, inability to predict what that provisioning needs to be by time of day, by scale, and being able to then provision the appropriate amount of capacity for that period of time leads to wastage. And then there's also the other problems that are related to not having the right reliability practices. Supposedly, you don't have checkpointing in training. You're going to lose days of compute if you're not able to resume from a checkpoint where there is a node failure, or if you don't architect for network redundancy, that could lead to GPU underutilization as well.
No, that's fantastic. So just to play this back, I think I heard 2 or 3 themes, and I'm going to get a question for you, Chris. But I think what I heard was, one, there's a inefficiency in allocation itself that's coming from scheduler, from sort of, do I have enough jobs, or am I over provisioned in terms of capacity relative to sort of maybe provisioning for peak load as opposed to average load. So there's the first inefficiency you mentioned is almost an inefficiency around allocating GPUs to where is something even running on those GPUs, or do I have idle capacity in the GPU infrastructure I've provisioned? The second one you touched on, Vinita, is how often am I actually running compute, or am I is my compute waiting for things like not enough memory, not enough network, et cetera, or even reliability failures that are causing GPUs to not be utilized? That was the second dimension that you called out as well. And inference in particular, the unpredictability of the load might cause you to have idle times. And so how do you manage all of that? And all of those lead to a sort of lower utilization. If I play back what I heard, Vinita, as some of the themes. Chris, you've not just in your current company, but even as part of VAST, where you've seen lots of enterprise deployments and neo cloud deployments. What are you seeing in terms of best practices that companies are embracing around managing utilization of their GPU clusters?
Yeah, I think what I would add to what Vinita started with is we have a tendency to, as an industry right now, to overlook how the applications are actually constructed and the actual resources that that application based on the construction are going to require. I think for most of the IT infrastructure of the world, we've gotten really good at understanding that. We've been doing it for 30 or 40 years. We're good. We're not good at this yet. Model selection, how you do, data communications, data unloading into the inference. All these things are really, really, really impactful on asset utilization. And so, if you don't profile or have some way of having a more accurate prediction of model of application behavior, you're going to over provision just because you can't take the SLA hit. And so we think that's a big part of it. So yes, I think we've discussed the very, very core things around just classic over provisioning around, especially model training. But when it comes to inference, I think people underestimate the application construction as the actual leading problem in really getting the infrastructure deployed and tuned just correctly. We work with a client in the Middle East who's had to create a proving ground essentially. So they would do their application development on a hyperscaler, but then they would move it into a relatively small, physical, under their control application or physical environment, a stand-up, so they could actually start to do scale YOLO testing and everything else before they went and actually bought a bunch of gear because they gotten burned too many times by over provisioning, right? And so this testing protocol, post-application development is really, really important for tuning the actual production environments.
Got it.
And if
Yeah, I
I may
want to, yeah, please.
One other thing, just to add to what Chris was mentioning, right? Especially, I think when it comes to inference, we are still determining how to optimize inference, and there are 7 layers associated with it. At the model layer, you're doing at the framework layer or the engine layer, and it's quite complex. So a lot of times, I think customers are in discovery mode. They are over provisioning to understand, okay, can we run this effectively? And then when they start to optimize at every layer, it is quite complex to do this. But once they start to optimize at every layer, you're able to then right size. I think it is also important to sort of look at, how an inference stack is now being built up and how much of it can be actually done in a full stack manner where you're able to get, let's say, an optimized inference system that has where we are thinking through the cache aware routing or disaggregated serving and full stack reliability, right? From checkpointing to redundant networking to automated failover, et cetera.
No, this is interesting. I want to go back to the idea because so much of the literature in optimizing training or even optimizing inference tends to concentrate on what can I do at the model level. And so whether it's types of parallelism, it's really fine-tuning exactly how your training algorithms are running. And those are, of course, where deeply technical papers have all come out. And but I want to go back to what I'm hearing and what I've also observed, specifically going back to the same company, 30% of the available GPU hours, so purchased GPU hours, are lost to where nothing is even provisioned to run on those GPUs, right? And so this is simply an inefficiency at the allocation layer, which is, am I even running a workload, forgetting about how efficiently the workload is running on that underlying infrastructure, between schedulers that allocate jobs to GPUs, between jobs that require proximal placement of GPUs, between jobs that require a certain minimum number of GPUs to be allocated to them, otherwise they cannot run. For all of those reasons, you're finding idle capacity and yet jobs waiting in the scheduler that cannot find capacity to be balanced against. So I just want to talk about that a little bit more. How significant a factor is that in training? And what I'm also hearing in inference, it's compounded by the fact that my incoming load is unpredictable and highly variable. So do I have static infrastructure, in which case I have to provision for peak inference demand? Or do I go host somewhere where I'm essentially using elastic resources that can scale up and scale down quickly? So Can you touch on that a little bit more? Both of you have touched briefly on this. So I'd love to understand how deep a problem is this and why is it such a big problem?
Well, I think as far as the 30%, example you're giving, Suresh, is I think there's a couple things. One of them is organizational structure in the firm, right? Is that there's islands of work going on, and they're not really always coordinating. We find this, very, very commonly. We find that the IT guys, the AI COE, and the line of business guys don't always synchronize particularly well. So they've maybe got together and bought or got access to through a neo cloud or some other place a pool of GPUs and resources, but they're really not combining their projects in order to be able to take advantage of it. So there's a humans factors piece to it without question. The other issue is you may have reserved a bunch of time for like a model training, and then the model training goes wrong, and you start to realize that it's not gonna complete, so you pull back. And now all that time that was reserved for that job is now going to sit idle unless somebody else can be scheduled in on top of it. We have a tendency to kind of idealize model training as this nice linear process that works every time. The truth
Right.
is that is not that is not how it really goes, right? So I think that those things have always compounded, and we've seen that in a lot of the work we've done with neoclouds around the world, where their business model is to just give you the reserved capacity because of this variability in the actual production time that someone takes, because there's a lot of variables. There's a lot of learning. There's a lot of mistakes made. You have a bad data set. You start to realize the model's not converging, and you're going to stop and stop using the GPUs for a while. So I think that's a big part of that utilization is those human factors and also just the state of the science, to be frank.
Understood. Vinita, I'm just curious, sort of, if you think about what are the metrics that one might track around this gross utilization, but it doesn't feel like even that is easy to track. So, any sense for what are the biggest factors to track as you think about optimizing GPU cluster utilization and sort of maximizing that, whether it's in training or inference? And these are obviously, I'm guessing, separate metrics that you would want to track in these two different use cases.
Yes. I mean, when it comes to utilization, we're certainly always looking at that number very closely. It's by cluster, by workload type, by time of day. Really, you have to get very deep into understanding what that is. Why are we seeing lower utilization rates? And a lot of it comes back to even what Chris just touched upon, which is, do you have operational efficiency in the way that your teams know how to handle a problem that arises? If there's an operational failure, what does it take? How quickly can that be resolved? So you are also looking at, I think, measuring efficiencies in your operational run books. You're looking at efficiency in training jobs completing, and if it's not completed, diving deep into understanding why that happened, what was the cause for it. And a lot of times you'll have to track the reliability of your infrastructure, which is failures, if the failures happened, if they're bottlenecked, network bottlenecks, or if there's any sort of model serving redundancy issues.
Totally makes sense. Chris, any sense of what are the key metrics that you would want to track as you think about, am I, as an enterprise, running my GPU clusters in the most efficient manner to increase utilization in particular?
Yeah, I think Vinita's got the basic ones, especially for model training. What I'll tell you is that it's for inference, I wouldn't say there's a good set of metrics today. There's so many different inference infrastructures. Am I trying to pile everybody into an MVL 72, or am I got a bunch of RTX 6000 Pros sitting out there, right? And how distributed is that? And I haven't seen, quite honestly, a pattern of good governance of that. That I would be, that I feel comfortable recommending. It's also very application variable. I think we've touched on that. Is end user behavior matters on the inference side very, very much. But the architectural dissimilarities between different customers trying to do inference is so high right now because there is not a reference architecture out there today. So there's little consistency, and I think everybody's struggling with this issue.
That's a great observation. I can certainly see the high variability in inference architectures, inference deployments, even learning curves. So that totally makes sense. I guess, one of the things that came out is that operational best practices matter an enormous amount. And you talked about that. Nita. This leads me to another question around sort of how do I make a trade-off in how do I trade off the deployment of infrastructure? Should I, as an enterprise, try and do that as an on-prem infrastructure? Do I have the operational capability to run that? Should I? There was a time where the default answer for new applications was I'd go to the cloud, but the economics, particularly at the cost levels that AI infrastructure runs at, are punishing, and public cloud deployments tend to be expensive if you think about it on a variable cost basis, although it's not clear what happens once you factor in that maybe the operational effectiveness of running that may be better in a public cloud than perhaps the skills exist on-prem. And then you have a new set of alternatives in the form of neo clouds that are highly specialized on running AI infrastructure, are more cost effective than public clouds, and yet may not have all of the surrounding infrastructure that public clouds do have for other mainstream enterprise workloads. Sorry, long context, but I'm curious about how should enterprise decision makers, infrastructure decision makers, think about the choice of on-prem versus public cloud versus neo cloud. I'm guessing, Vinita, the first answer is always choose Nebius, but
Always,
setting that
yeah.
aside, setting that aside, how would you think
Yes.
about that?
Yeah, exactly why all the problems that you outlined is why Nibius is investing in a fully operational stack. But let's go back to the details behind it, right? I do think that when customers are experimenting with this, when you're doing pilots, you can choose any environment you want because you're running it perhaps in a couple of GPUs with some synthetic data, some test, lower number of users. But when you now need to, 10x it or 100x it and compute real data pipelines, SLAs, this is where you'd have to sort of look at what the business case is, what you're trying to drive with respect to business outputs, and then how does that compare to costs that you would get from both on-prem as well as a cloud provider. I think from the neo cloud point of view, and true probably for cloud providers is that we are thinking of it as a fully managed service, right? So we are not only thinking about, okay, what do we need to do to deliver the GPUs, but also the operational aspects, the security, the governance, the observability. When a workload is in production, you're going to need access integration, audit logs, residency compliance, rollback capabilities, et cetera. You're also going to need a lot of that operational excellence that we just mentioned, right? So I think it feels like that when it comes to being able to think of the total cost of ownership of running this workload in production, one must be thinking about not only, what would it take for me to run these workloads on a GPU, on a per GPU cost for the actual hard compute itself, but also looking at how are you going to be able to run this with operational excellence and the degree of security and scalability that you need for those workloads.
That makes sense. I guess and this is really where the neoclouds have done an incredible job of, especially the ones that have really invested in technical competence, operational competence, are not only able to provide GPUs at a cost-effective per GPU price, but also things like how long does it take for me to get a new node when one of my nodes experiences a failure? How quickly does a taint signal propagate so I, as a model owner, can do something about a likely to fail node, et cetera. And so those have been really, really what sets the certainly tier one neoclouds apart. But there is one question that I've wondered about. The more that AI becomes part of the fabric of how your applications run and all of your workloads, the more there is a need to integrate with existing IT infrastructure, with existing applications, and certainly with existing data that needs to become part of how you train, how you sort of constantly fine tune, et cetera. And so, Chris, you in particular, you consult with a lot of enterprises. One of your pet themes has been that you can't ignore the massive amount of existing infrastructure, data, workloads, practices that are already in place. Doesn't that make it more challenging to go to a neo cloud if some of it is in potentially public clouds or on-prem, but neo clouds are the best at running AI?
Yeah, it's an excellent question, and you're right. This is exactly what our business focuses on, is helping clients with this. A couple things I'd start with. First is that different platforms have different value propositions to enterprises today. I would say it's almost impossible to argue that you should develop an AI application anywhere but one of the hyperscalers. Your ability to have flexibility of model choice and different assets and utilization very, very quickly to do application development, I think is unparalleled. I think anybody who's trying to compete with that is probably in a bad position. The amount of money that the big hyperscalers have invested in the developer experience is really something you've got to respect, and that quite honestly our customers want to use. Even if you look at a partner like a GSI, they have thousands and thousands of developers who are versed in developing on those platforms. So you don't really want to upset that. So that's the first thing. I do absolutely agree, though, that where it runs is very, very important. The first thing is you want to avoid lock-in. So a lot of the work, to be very frank, in the AI industry right now is all about people trying to get locked into a platform. That's what and quite honestly, the problem with that for the enterprise is I totally get why as a business you'd want to have that, is that lock-in is the absolute opposite of the key point here, which is AI workloads for enterprise are essentially hybrid. You're going to have data coming from everywhere. You're going to have resources from everywhere. And so you have to be able to architect in a hybrid way. So the idea of choosing any platform that locks you into a single API set and a single data source and the rest of it, or you have to move everything in there, is really a non-starter for most significant enterprise projects. So our view on it is develop where you want to develop, but with the idea that you're going to then deploy and run in places that make sense for that application, that user, the end user, the cost, and everything else we've talked about already today. So one of the things you need to think about is you look at some of the neoclouds, what we love what Nebius is doing is they understand that it's not, you can't use exactly the same service catalog that you did to be a model trainer to do an enterprise application. And this is the core point, right? Is if you actually look at an enterprise application, it has all kinds of services it requires. A bunch of stuff on CPUs, not just GPUs, right? I need an optical character reader. I need a database, a traditional database, not just a vector database. I need all these other resources in order to make an application work. So you have core systems, and a lot of those are legacy. They may be a SaaS system like an ERP system, or they could be an on-prem storage array, or it could be all those kinds of things, right? And then you have to be able to move data around and manage that intelligently. You have to be able to deal with identity management and security and compliance issues. So for any part of a neo cloud to want to be part of this, is they have to have the desire to deal with all these extra issues. I was with a large banking customer just last night, and they said, the biggest thing that's stopping them from using a lot of the neo cloud type of resources is security and compliance and identity management. It's just that simple. So I think we're seeing a few of the neo clouds start to transition parts of their business from the traditional I'm a model builder runtime environment to we're trying to solve large scale enterprise deployments, and that's just going to be an increasing service catalog from them. The last is, of course, the customer does it on-prem or does it in a colo. Almost every enterprise has to do it really in a colo today. It's not there's no legacy enterprise data center that has the power to do this to the rack, right? I mean, just know that that's a limitation. But I think the key things to take away are develop wherever you're comfortable. Don't get locked into a platform. Understand that you're going to want to move that application through its life cycle to different runtime environments, and then pick runtime environments that can actually provide an entire stack of services and the interconnectivity in the hybrid environment in order for you to be successfully able to scale the application.
Got it. Fantastic. There's so many angles that we could pick up on from here, but I want to pick one that maybe slightly makes it controversial and sort of draw out a contrast between what both of you are saying and just tease that apart a little bit more. I think when you say that in the context of an enterprise application, there are hundreds of services that surround the application, not just the availability of sort of GPU-specific infrastructure or AI-specific infrastructure. And Vinita, you commented on the fact that you're already starting to have to provide those other services as well. But in the extreme, does that mean that as time progresses and as neoclouds are successfully executing to growth strategies, that they will have to look more and more like a public cloud in the plethora of services they offer? Or is it even possible to say you can still have enterprise applications that need all those services, but not look like a public cloud? I'm sort of trying to understand here,
Yeah.
is there a way to distinguish the nature of these two?
Yeah. Yeah. Great question. I do think in terms of scale, we would probably want to add hyper to our
Yeah, fair.
our
Neo.
positioning, right? Rather than neo. But I think the difference that I see is that we are building our cloud with AI in mind from day one. So it's a very specialized AI cloud. And so when we think about the workloads that are running on our systems, there are mostly customers saying that we're running these, we need GPU, extensive GPU capacity to run these workloads. There may be some components that don't need that. They need the CPU, they need some other services like you just outlined, right? There may be some database services, some other, some identity services, lots of other security and governance capabilities, which we will continue to add because those are core to running AI workloads. And so I do think that we will grow in scale and services to support the needs of enterprise. Are we going to look exactly like the hyperscalers of today? Today, perhaps not, because I think the core requirements for AI workloads is shifting pretty rapidly.
No, that is very fair. In fact, I think so if I play this back, it almost feels like the successful hyper neo clouds, making up a term here, Vinita, are going to start with AI-centric infrastructure and then add what it takes to expand into what a full enterprise application that is AI built from the ground up, knowing AI exists, might need. Whereas maybe the existing public clouds are starting with a massive set of services and stripping gradually into sort of how do we add AI and not necessarily starting with an AI first mindset. Whether they end up in the same place, it's an interesting question that remains to be seen. Let
Right.
me just
Yeah.
ask a question back. If I were to say I'm an enterprise today, and today, what should I expect in terms of differences between the public cloud and neo cloud in terms of my own experience, whether good or bad? Certainly, it feels like the cost effectiveness is higher. It also feels like there's a set of mature operational practices that sometimes feel like the new clouds have perfected even more. But I'm curious, as an enterprise, what should I expect as a difference between these?
Yeah. Yeah. Great question. I think it comes down to the application and the use case. So assume if you're an existing software as a service um, product company and you've got a range of services that depend on hundreds of other services that are being offered by the hyperscalers. And if that's the case, then you're essentially looking at what is the new AI first capabilities that you're adding to your application, and how are you going to architect that to be able to run these workloads effectively on your existing cloud or potentially a neo cloud. And the decision factor, in my opinion, will come down to, what is the need, what is the capacity need, how quickly do you need it, and at what cost, right? You're going to probably lead into this capacity discussion very soon, but it's definitely going to be a significant factor because people are planning 6 months in advance and trying to understand what is the capacity do I need for the AI capability that I'm adding to my applications. If you're a brand new company, right, you're AI native company, then I think the decision is a little easier because you're probably got a fewer set of services that your application is dependent on, and then you're essentially looking at where can I run my training and inference workloads at scale and as efficiently as I want it to be, and I think I feel a lot of the work that we've done in terms of having a fully integrated AI stack is going to be beneficial for those companies.
And Chris, you said something that I just want to go back on, which is indeed about capacity, but it almost feels like the choice of on-prem is harder and harder when you think about the power envelope, the rethinking of what your data center should be capable of when it comes to running modern AI GPU systems, right? Rack scale systems that need very specific data center changes to be made and so on. So is running on-prem for most enterprises not even practical? It's either a colo, as you said, or a neo cloud or a public cloud. Is that pretty much the case?
Yeah, that's our view. We don't see a lot of retrofitting of legacy data centers in order to deal with the power, specifically the power and cooling issues. That's just not. I don't know many CFOs that would sign off on that, considering the rapid change. If a year and a half ago you'd sign off on 40 kilowatts to the rack as your next design, you'd be really upset with the way things are today. And we're pushing 150 kilowatts a rack and heading towards 500, right? So no, I think the idea that these systems are going to run in a corporate owned data center is not likely. We haven't seen it. Um, so yeah, it's going to be a colo where I can get the power and space and cooling I need, or it's going to be a neo cloud. The thing I'd add to the neo cloud piece is the thing that's going to work well for the neo clouds in the near term, assuming they're willing, is most of the projects are actually going to be bespoke. The difference between the traditional hyperscaler and a Nebius, as an example, is AWS needs to have everything for everybody. They have to be Walmart or Target or pick your favorite, right? Where the things that are going to end up in the near term in the neo cloud ecosystem are going to be already very bespoke. They're going to walk in and they say, "Here's my bill of materials. Here are the service catalogs I need. Here's the connectivity I need." And this for the neo cloud that wants to do that, because it is a different business than what a lot of them are in today. And much more physical security and logical security, much more networking. There's a lot of things you have to do just to be ready for that. But I don't think they have to maintain a big general purpose service catalog to be able to be really effective partners with enterprise customers. They can just say but they need a systems integration partner or to do it themselves in order to help build that. But I think they can be kind of a super colo where it's not, it's a place I can bring my project level to, and I don't have to, once I've developed it again, in our theory, I've developed it at a place where I have, all the resources available to me, but then I go and tailor that operating environment in some place that can give me a much better price performance in the build and an SLA than I can get on a traditional hyperscaler.
Fantastic. I want to sort of move up the layer a little bit from choice of where you deploy your infrastructure into another place, which is an intersection between sort of supply chain and GPU economics, which is around really where should you invest from a model perspective. And Vinita, I'll say this, there's a lot of discussion around open models versus not small language models versus large language models, APIs versus having your own fine-tuned version. And if I go back a year, maybe a year and a half ago, it felt like we were at a point where we said, just RAG is going to solve all problems. Let's just take all of our enterprise data, have a really good RAG implementation in place, and then deal with a straightforward off-the-shelf LLM, whether through API or in-house, and I should be able to do a pretty good job. It's since then, there's a lot more buzz around fine-tuning, post-training, reinforcement learning, et cetera. So how should companies think about their investments on the training front to begin with? How should they think about the value of how much they invest in training and what kind of investment that looks like?
Yeah, great question. I think when you ask the question when to pre-train, almost never. It feels
Right.
like for every enterprise, right? Pre-training for frontier model is for frontier model labs and few organizations that are really truly unique, maybe massive data sets, very deep pockets. And as you know, it's that investment is only going up. And general purpose models are actually really, really effective at this time. So, I think pre-training is likely not in most companies' game. It is going to be very, very few companies such as the Metas of the world, Meta, OpenAI, Anthropic, and some of the other open source model labs that are going to be doing pre-training. When it comes to fine-tuning, most companies have some domain-specific data, right? That materially changes. And therefore, you want your model to have the most recent data, and any sort of general purpose model is just not good enough out of the box. So fine-tune is still very, very relevant, and especially for domain-specific tasks, let's say in healthcare or legal or financial services or manufacturing. And it's really the middle ground between, pre-training and I guess more specialized prompt engineering sort of thing. And we see a lot of companies that wanting to do this fine tuning, and I think that's going to continue to be a trend. We're also starting to see very clear, curiosity on experimentation, especially by data scientists, to say, do we really need, a large language model? Can we use small language models for specific use cases? Because you may not have to want to incur, you want for cost advantages, you're looking at smaller models. I think also the other debate that continues to be, is a very interesting one, is open source versus closed source models. At the beginning of last year, I was on a panel discussion where I thought, 2025 was going to be the year where open source models would be very comparable. I'm saying 90% of, in functionality to closed source models, and perhaps 1/5 the cost, or even 1/10 the cost. By the end of 2025. That didn't pan out in 2025. So I'm very curious to see what happens in 2026. I think there is definitely, I see a lot of new models being released in open source, KBK 2.5 or Minimax, and they're doing an amazing job. I would be watching very carefully to see what the economics of those models, and actually what the performance of those models are in 2026.
So maybe this is my confusion on terminology, and I just want to understand this a bit further. When I think about pre-training, and when you made the comment about it's going to come down to a handful of companies that should really invest in pre-training from the ground up, and yet sort of to both of you, there are lots of companies that we're working with, a collaboration company that's really a video collaboration platform that is using several thousand GPUs and training those GPUs on all of the constant sort of video chats that are taking place, et cetera. Another one that's a social networking company with hundreds of millions of users that is using it for guided conversations for users, and so on and so forth. And they are also deploying several thousand GPUs. A pharmaceutical company that we've engaged with quite heavily, that's also using several thousand GPUs for sort of drug discovery research. Automotive company that seems to be north of tens of thousands of GPUs. So where would you classify these? And it feels to me like there are several industries where the training intensity is high, and high enough that I wonder if it's not pre-training and if it's actually fine-tuning. It feels unfair to call it fine-tuning. So maybe without getting into the nuances of exactly how are they training, I'm just curious how to draw the line between infrastructure intensity and the amount of training work that's being done. And both of you, I'd love to get your perspective on that.
Yeah, I would have one comment there. Is I think the question to ask is, what model are they starting with,
Right.
right? And so that gives you a very clear indicator of whether they're
Indeed, indeed,
training or fine.
indeed.
Yeah, and I think you also give some examples, Suresh, of some pretty wildly different use cases, right? So
Indeed.
in the pharmaceutical space, they're absolutely doing pre-training. They've got the economic incentive to build their own models, given that they have a very, very defined use case. They don't really need to have a general purpose model. If you're doing drug discovery and all of that. I think that you do see that when an enterprise is of size and resource to be able to tailor it to their business, I think they're going to go for that. It gives them a competitive advantage. Most of the Fortune 500, though, quite honestly, is really fine tuning, right? That's where they are. The other thing about that community I think is really important is they're a little overwhelmed right now by the model selection choice, right? And keeping up. And just thinking about the last 90 days, maybe 128 days, 120 days of the industry. 120 days ago, it was Gemini is like killing everybody. It's the best model out there, and then OpenAI is falling behind. And then OpenAI kind of came back. This is like Star Wars editions, right? And then the return of the OpenAI. Now all of a sudden it's Anthropic's, the hot thing, right? That is driving the enterprise decision makers crazy, right? And they're waiting for things to settle down. A customer we met with recently had developed an entire process of how they evaluate a model and then provide guidance, the standardization within their own firm on what models to use. And they've gotten to a point where it's so chaotic, they can only do that evaluation once every 6 months, right? So the model industry is really a tough place for an enterprise to match their pace of business to that model industry. And what you're
Right.
going to find very quickly, quite honestly, is enterprises that are going to settle on a model, and then that model is going to be basically a version control problem because they want to continue to use the legacy model that they've kind of certified for their use. And of course, the model business is not set up that way. I can't go back and use an older version of the model. So this is going to come to a head very quickly between enterprise users and model builders, is they need some stability in these things. Is because people have a tendency to forget what the model is. The
Yeah.
model is the decision-making entry. I am outsourcing decision-making to this model. And every time the model builder changes it or I think about changing it, I'm changing decision maker. And I've got to make sure I'm not making a mistake there. So this is another of those big things between where the AI people think about it one way and the IT people think about it another way. Is we need to probably get to an industry standard of model versioning that allows an enterprise to settle and then put things into production with an engine, a model that they trust, and to have some longevity around that.
Got it. Just playing back some themes, and then I have a couple of follow-up questions. One, I think I'm generally hearing pre-training is for a few, not for most. Even when you're doing pre-training in specialized industries, it'll be the largest and very, very obvious use cases where you might encounter pre-training. Most should probably think about some combination of fine-tuning. Of course, RAG is something that you'll always do, but perhaps combine that with fine-tuning might be where most enterprises find value. The second thing that both of you called out is that the use of enterprise adoption of models is going to be slower than the pace at which models themselves evolve. And that may be okay, because in the end, the enterprises are judging that based on how good is the model at delivering essentially the kind of judgments it's supposed to make or decisions it's supposed to make. And if it's fit for purpose and you're measuring other attributes like accuracy and sort of things of that nature, then you don't need to necessarily move up fast. But the last dimension I want to pick up on is or a dimension that you called out is open source models, Vinita. It's really interesting because I think if you take a US perspective, then we are often we'll come down to talking about these three big models and the fight between the three big models. And yet open models from China in places like Asia, it seems like distilling open models, quantizing open models to create enterprise small language models for their own use, et cetera, is quite significant. So maybe the question here is, sort of when do you go towards what are maybe two or three factors, Vinita, that guide the choice between I want to use an API and now is the time when I need to shift from using an API to perhaps using my own fine-tuned model, whether that's open models or models from the large commercial vendors that I then fine-tune. How do I think about what is that break point when I should make the move?
Yeah. Yeah, it's a great question. And I'd say I'd segue it into how should we, enterprise should be thinking about inference because, we talked a lot about training, but 80, I mean, very, very rapidly, a significant portion of the cost
Indeed.
in AI is going to be inference. And and what most companies are going to have to think about is how they're going to optimize their inference pipeline. What do they invest into that delivers those model outputs that ultimately delivers business outcomes, right? And the particular business use cases where they don't actually have to use a fine-tuned model, but can use a general purpose model, then you sort of start looking at what is the best model for those use cases. Can it be open source? Can it be commercial? And I think that, predominantly these days we're definitely seeing enterprises at scale adopting the closed source models just because they are extremely effective today. In benchmarking, they're consistent and they're showing great output, continuous innovation. We're seeing that with open source models as well. But I think the public trust in trust in these
Mhm.
open
Mhm.
source models has to be built. It also comes down to economics, right? If you get 90% of the capability at one fifth of the cost, that might be the inflection point, right? We're waiting for that to happen. And perhaps, with some degree of confidence that the model creators have built-in security, built-in governance into their model creation process. So I think those are the factors. It is also, important for companies to be thinking in terms of inference optimization, just everything in regards to, what are you running these workloads, these inference workloads for? Is it batch? Is it continuous, right? And then are you doing all of the things that is important for delivering great performance for inference, which is the cache routing, model distillation, speculative decoding, quantization, et cetera, et cetera. So there's a lot of places where you can optimize, but I'd say, going back to your question, yes, it will be a combination of choosing your model and then choosing for your specific use case and also doing everything that's required to make that workload cost effective.
Indeed. And certainly the number of techniques to make models cost effective goes well beyond choice of model and specifically to techniques that you take on, like you said, quantization and a whole bunch of techniques that you called out, Vinita. And this actually brings me to maybe the last topic today, which is around just how do you run reliable AI infrastructure? What is clear, I mean, I think there was a recent Flexential report that called out, I think something like 59% of the companies surveyed, and there were about 350 companies reported basically bandwidth issues and latency issues as they started scaling up their AI deployments. And perhaps even more significantly, the bedrock of their entire AI is really what does the data pipeline look like and how do they feed the AI engines, whether that's for inference or for training purposes. And so that was a big source of concern as well. So maybe, Chris, you've done a bunch of integrations. What are the top three things that enterprises must think about as they start bringing AI to bear in the enterprise, and how does, as it relates to sort of integration with the rest of the enterprise infrastructure?
Yeah, so I think there's a couple things. First of all, one of the topics we don't talk about enough historically has been SLA, right? You've got to design with a known SLA from the start. You can't bolt that on later. So that is built into the application development. It's built into the infrastructure choices you make. It's built to where you run, right? Depending on where your data is and all these things. So I think SLA decision making upfront, just like we're used to with enterprise applications, has to come into the AI fold. We've also learned that you don't really need to move as much data around as you thought you did. There used to be an idea that said, hey, I have to move large quantities of my data that I'm going to use for RAG very geographically close to my model. And the truth is our experience has been that the data movement is actually relatively simple, and it's much less because much of the data that is being used is the same data over and over and over again. I'm not trying to move an entire 5 petabyte, kind of logical store. I'm using the most current data. If you look like an airline, right? I'm not really having to worry about flights that happened in the past. I have to worry about flights that are happening now and happening in the future. It's a much smaller set of the total data that any airline actually holds. So intelligent data, tagging and understanding what is actually actionable data and useful data for the application really results in much, much more of a streamline of data movement and data management out there. So I think that helps an awful lot. The third piece I would say is around the thing that we haven't really gotten to yet is stability of GPUs from an uptime perspective. This is where things get tricky, right? We all know if you've been in this industry any amount of time, and I'm sure folks at places like Nebius could tell horror stories of kind of the fragility and uptime problems around some of these large GPU cluster areas, right? That's got to improve. And right now, the customer bears the cost of over provisioning, as we've already discussed today, in order to cover that. We're looking for more enterprise quality, especially inference infrastructure that allows the customer to more accurately tailor their infrastructure so as not to have to over provision. But that means it has to meet that SLA we started with. And we're really missing that connection at this point. I'm hoping that the Broadcoms and the Intels of the world, as they come on with more of their kind of enterprise history, will end up adding additional infrastructures that would help a lot.
That's a great comment. I wanted to get closer to the end with this one, which is I think Meta's admittedly in training reliability paper, which has been cited numerous times, talks about I think failures in 1,000 GPU cluster running at about 3 times a day. I think it's a mean time to failure of roughly 7.9 hours. In
Yes.
16K GPU clusters, it's about less than 2 hours mean time to failure. So that's
Right.
sort of a failure every 2 hours or a disruptive event every 2 hours. But the problem is these disruptive events cause you to restart your workload if it's training. And in the case of inference, you have to figure out exactly how to reroute and so on. And so
Well,
that's a
in context, right? And
indeed, indeed. And
driving
it
the end user
feels
crazy.
exactly, exactly. And so it feels like fault tolerance is a software problem, not just a hardware reliability issue. And so, Vinita, any comments? It almost feels like the application layer is not caught up to what may be hard to fix just at the hardware layer, given how demanding and how distributed the underlying applications are and what they demand on the infrastructure.
Yeah, 100%. I mean, quite often we are hearing from customers saying, "Hey, what is, what should be a high availability infrastructure?" And honestly, it takes a lot of detailed planning for it, and some of it I think it's still to be discovered because GPUs are very expensive, unlike CPUs, and the same high availability principles that we may have placed on CPUs cannot be applied that simply in the GPU world. And therefore, you're absolutely right. Some of it we can plan for, we can architect, but a lot of it we'll have to still continue to define as all of the entire hardware and software layers evolve in the upcoming years. And I think the customers are recognize this, right? And so they are looking at what workloads are appropriate for what is the purpose, right? It's not technology first. They're going back to what is the purpose, and what is the relevant data that's required for that purpose, and what is it that we can do that can be potentially ephemeral to ensure that we have, keep the costs low, but at the same time have a degree of reliability. And we, as the neo cloud providers, we are continuously trying to reduce that complexity for our customers. We try to, even as we mentioned, there's complexity at the model layer, the inference layer, the actual hardware itself, and failures associated with it. And so I think that the right questions to ask, customers should be asking from their providers are what do you have in place to make sure that we are able
Indeed.
to deliver these systems reliably.
Indeed. And I do think this is exactly right. As much as we've talked about utilization and supply chain and so on, the one emotionally pain, every time we've talked to customers, the area that's visceral, that's emotional is failures happen all the time. I don't know exactly why it happened. There's no fault tolerance at the infrastructure layer when these failures happen. Restarting jobs is extremely painful. Answering model owners on why my model is running slow or why it's restarting is really painful. And so definitely, I think fault tolerance is a topic that I think is very, very relevant in many of these constructs. At the risk of, I have 2 minutes, so rather than summarizing what we touched on, which I was about to do, I'd rather just ask you one question, which is sort of just the last one. Quickly, what widely held assumption about AI infrastructure do you think is the most wrong? And what do you think is the one capability 2 years from now that would be considered paramount for enterprise decision makers? So what is the myth today, and what do you think is perhaps the most important capability in making AI successful to each of you? And we'll end with that.
I'll let Chris go first.
Um, I think the biggest myth is that walled garden infrastructure is the future. That I'm going to check all my data and applications into a single platform and I'm going to be happy. I think that's absolutely the myth. I think the biggest thing that will happen that we'll be looking at 2 years from now is we'll have actually understood how inference works. I think that we really don't know how to do that at scale, to be very honest. And the second thing goes back to a conversation we've touched. I think that there will be a resurgence in open source models, especially in the United States. You see them more available in other places, more accepted. But I think the United States is going to have to, there's going to be much more significant open source. We're going to have our Linux and Red Hat movement around AI.
Yeah, I love everything that you said, Chris. I completely agree. And I just wanted to add that, some of this movement is already happening because we are hearing of hyperscalers building, hyper low latency interconnects between the clouds, which didn't, I mean, we talked a lot about hybrid
Wow.
in the past, but that never happened. And now it is happening. So that's very exciting. I absolutely think it's going to be a pretty distributed world. And I can't wait to see when the open source models overtakes the closed source models.
Well, with that, I just want to thank the two of you for being such great panelists. Really, a lot of great insights. Appreciate that very much. And I want to thank everyone listening for being with us for the last hour. Thank you very much. I hope you all enjoyed it. Take care.
Thanks, Suresh. Thank you, the Clockworks team.
Thank you.